GDG Clouders! How are you today? It's a beautiful sunny day here in the part where we live in London. Unfortunately, you can't see it because I had to close the window so that the light wouldn't be on the way. We're very excited to have Jéssica here today. If you were here, I think it was a couple of Saturdays ago, she gave a talk, and it was her very first talk in English, even though she has given many talks in Brazilian Portuguese before. And this one is going to be more technical, about TensorFlow. It's going to be very interesting. I'm looking forward to it. It's a piece of technology which is very new and up to date. It's something interesting for you to learn, especially now that we're more stuck inside of the house. And I think it's interesting if you have the time and the will to learn something new or to hone your skills, this is the time. If you would like to give a talk at GDG Cloud London, we welcome mostly everyone to give a talk. It doesn't matter if you haven't given a talk before. We can help you out, we can have a look at your slides, and we can help you become a speaker as well. Hello, Kelvin. Hello, Monica. Eddie, hi. Saverio from GDG Cloud London is here as well. Who else do we have here today? In the meantime, while you respond to my question, I'm going to invite Jéssica here to say a few words before she starts her talk. Come on here, Jéssica.
Oh, let's go.
Hello.
Hello, Amanda. First, good afternoon from Brazil.
What time is it in Brazil?
It's 3:51 p.m.
Okay, so you mostly just had lunch.
Yes, exactly.
We see some familiar faces here. Fernando, Pablo.
Fernando is here.
Yeah, this Fernando here.
Thank you, my friends.
So, Jéssica, where can they find you online? Which social media are you on?
Oh, yes. In presentation final, I share my contacts. LinkedIn, email, and Twitter.
Very good.
I promise I share.
Very good. So your last talk here was about fake, what was the title? Fake data, no, fake news.
Fake news.
Fake news. Now we're going towards TensorFlow
and Keras. Let's talk about neural network.
Okay, very good. So now you got in the hang of speaking in English, huh? You use now your professional speaker in English.
Oh my God.
Where are you speaking from? I want to know more about the people here. Remember that you can share your questions. When you say something, I can bring your questions and the things that you're saying here on top of the presentation. So it doesn't matter that we are remote, that we can't have, oh, from Argentina too. It's not because we're not
Argentina. Okay, so good.
That we cannot interact. So you're here in real time. This is happening right now. So ask your questions, share your thoughts, so we can bring what you're saying here on top of the talk and also have your, I don't know if we will be able to answer all of your questions, but we can try to answer some of them.
Okay.
So we're going to start in 5 minutes. So I think now is the time to grab, bottle of water, tea, coffee, soda, whatever you're having there.
I love coffee.
Yeah?
Yes, coffee.
I'm more of a tea person. Coffee for me, I think it's more like an obligation when I have to be awake, when I have to focus.
Exactly.
Yeah. Empanadas.
I love Argentina. Medialunas. I love medialunas in Argentina.
They're very good.
I miss medialunas.
Argentina, Jessica.
I visited Argentina last year in April.
I think I ate a fruit. What's the name? Pomelo. I think it's from Argentina.
What?
Pomelo? I think that's the name. Maybe Pablo can tell us. Everyone, grab your drinks, comfortable seat, think of your questions, have a look at Jessica online, follow her on Twitter, on Instagram. We're going to start very soon.
We can talk of me through LinkedIn, Twitter, my email is my personal contact. And the last slide, I put my contact.
I'm curious to see the slides.
If you want to share, my Twitter is Jéssica Costa Davis.
Oh, I think I have it here. Yeah.
My Twitter, yes.
Pomelo. Yeah, I remember that fruit. You know what I love about this talks online, even though like there are some things that you can only have in the talks in person, now we can have people like you from Brazil real time speaking to us here. We have Sandeep here.
Work together through internet.
One world.
Yes.
Hi, Peter.
My friends are talking to me here.
Are they going to come to watch you live? We already have 27 people here. Learning from you. Maybe some people here in the UK and other parts of GMT plus or minus one are going to have dinner while
dinner?
Talk.
What time is it in London here now?
It's 8 p.m. I mean, 3 minutes to 8. Pete's on its way. I had my dinner just before the talk because I wanted to be here because I want to learn everything TensorFlow.
Exactly.
Ice cream, good call.
Dinner with TensorFlow. It's a good idea. I recommend.
I should have been the title, TensorFlow.
I prefer Python, but JavaScript is an option too.
Python. Oh my god, he's saying all these delicious things. 2 minutes to go. We're allowing some time for people to come. As we said in the agenda, we would have some opening remarks. If you find us through YouTube, we are a GDG group, a Google Developers group. This is our website, gdgcloud.com. If you're joining this call from a different part of the world, which is not in London, there are GDGs in many parts of the world. You have GDG in Rio de Janeiro, don't you, Jessica? There's a GDG there.
Today, I know. I was.
Oh, they're talking there today. Very good. So we're going to get started in 1 minute. I'm going to add her presentation in here so she's ready. And I'm going to remove myself from here because the stage is hers. So make sure you ask your questions and follow along. Thanks, Jessica.
Mexico. Mexico, Argentina, Brazil. I'm so proud. Can I start, Amanda?
Yeah, the stage is
Let's go. Let's go. Good afternoon, and I'm Jéssica. I was in the last presentation. I spoke about fake news. Today, I would like to talk Keras and TensorFlow, neural networks. It's important topic. Let's talk about it. Well, how to build your first neural network with TensorFlow and Keras. Hello, everyone. I love cats. I love cats. In my last presentation, I forgot my cats. It's horrible, but I love my cats. I never forget. Who I am? My name is Jéssica. I'm software engineer and data analyst in Rio de Janeiro, Brazil. Bachelor degree in information systems from Federal University of Sergipe. I have worked in technology community since 2016. It's my photo and other events in Florianopolis, Brazil. So, machine learning. What is machine learning? Machine learning is an application on artificial intelligence. It's important to emphasize. Machine learning is not equal artificial intelligence. It's an application of artificial intelligence first that provides systems the ability to automatically learn and improve from experience. It's similar our learning. When you were child, you learn through experience and repetition. Machines is the same thing. Through machine learning. IBM says the value of machine learning is that allows you to continue learning from data and predict the future. It's very important to business. Understand your business through data and predict the future from a business, science, many applications. Okay? But machine learning exists a long time. The term machine learning was created in 1959 by Arthur Lee Samuel, IBM researcher. But machine learning has grown up due to big data. But big data, what big data? Big data is any kind of data source. Big data is data source, people. Please understand. Big data is any kind of data source that has at least one for shared characteristics, called the 4 V's. Big data has 4 characteristics. Let's talk. Extremely large volumes of data. The ability to move the data and the high velocity of speed. An ever-expanding variety of data sources. Veracity is very important too. So data sources truly represent truth. IBM 2018. The 4 V's is important to understand what is big data, based on volume, velocity, variety, and veracity. But it's important to understand the machine learning process because it's complex. I make a simple process here, but this process is interactive, is repetitive. First step is collect data. Very important. Select your data set. Select data with relevant data, not every data, but all the data. Select data set with relevant data. Will help to better learning. you need to understand your objective and select relevant data. It's a collected data. After, you need to prepare this data. First, manage missing data points. It happens frequently. Clean data sets. Fix issues in data sets too. And split training set and test set. It's important in the process too. Training and test. I used to divide in 70% to training and 30% for test, but this can change. It's not an obligation. After, you need to train your model, but you need to choose an appropriate model. You can use decision trees, CVMs, Bayesian nets, neural networks, several options. But remember, you need to understand your data before. Train the data set to train this model. Train data set to train this model. You separate a training set and test set. Your training with training data set. After, you evaluate your model. Test accuracy, precision, loss, and other to evaluate your model. We have many metrics. You must choose the best for your model, for your algorithm. Let's talk about a biological exploration, the human network. We can see a representation of the human neuron. We have dendrites, nucleus. It's a cell body in our brain. Axon, myelin sheath, Schwann cell, node, hanvier, axon terminal. Remember this figure because it is very important to understand the artificial neuron, okay? Because artificial neuron is an inspiration of biological. It's a representation to artificial neuron. It's perceptor. We have constant 1, input x1, xn minus 1, xn. And weights. Weights is relevant. W0, W1 for each input. We have input and a weight. W1, W1 minus 1, Wn. But after, we have a math operation. The sum of multiplications, weights, and inputs. Weighted sum. After, we use a step function or activation functions. It exists many activation functions: sigmoid, ReLU, hyperbolic, softmax. You must choose the best for your model. Okay, it's a simple explain, but you need to study more to understand. This representation is very used in several neural networks. Okay, but we have a neural networks now. What is neural networks? A neural network attempted to mimic the way a human brain approaches problems and use layers of interconnected units to learn and infer relationships based on observed data. We have inputs and several neurons in layers, but we can have many layers. Input layer, she can receive the data, the inputs, and hiding layers, and after the output layer, the result. And this neuron happen many operations, mainly math operations. I don't like when people say me, Jéssica, neural network, machine learning, it's only many F's. It's wrong. Machine learning is based in mathematical fundamentals. It's based. Don't forget that. Now, we have a comparison and biological neuron and artificial neuron. We have, I would like to emphasize synapse. Synapse is the interconnection and between layers. Let's see. And the first figure, we have dendrites, that cell body, axon, and artificial neuron. But the second figure, we have two neurons in a synapse. Synapse is a connection between layers. It is an input layer. After the first hiding layer, the second hiding layer, for at least output layer. This representation is similar to how our brain works. But I would like to talk two talks very important in data analysis. Okay? Overfitting and underfitting. Please see this figure. We have three graphics. A graphic with underfitting, a graphic balanced, and a graphic with overfitting. This is two problems in data analysis. We need to avoid these problems in your analysis and your machine learning models. Overfitting occurs when your model achieves a high accuracy, but in training set. But it doesn't generalize well the testing set. Remember, we need the training set, but we need the testing set. Machine learning models must generalize the results and other sets, not only training set. In this case, we have overfitting. You need to avoid. Underfitting is other problem. Underfit occurs when your model can neither model training data nor generalize it to a new data. Nothing. It's problematic. We need to avoid these problems. And other presentation, we have you can talk how to avoid these problems in your machine learning models. Okay, it is some techniques to avoid, but I like to emphasize this problem because it's very common in our models. Now let's talk about the Tensorflow and Keras. I like to Tensorflow. It's perfect to me. Tensorflow is an end-to-end open source platform of machine learning. It's a platform. We have very modules, but in TensorFlow 2, we have Keras, but it's Keras. Keras is on a high-level neural network API. It's connected here now. Written in Python and capable of running on top of TensorFlow and other platforms. Piano, it's an example. To learn about TensorFlow, you can access tensorflow.org. We have many, it's very materials, courses, examples, tutorials. You access this website. It's very, very, very cool. But now, I choose algorithm to explain, to show in this presentation, regression. What is regression? In data analytics, and we have discrete values and continuous value. Continuous values are numbers. Discrete values, it's words. Discrete, it's categories. In a regression problem, we want to predict the output of continuous value like a price or probability. Your result is a continuous value, it's a number. In this graphic, we have linear regression, is the red line, and this data points is a prediction of linear regression in this case. Let's practice. I make a notebook. One moment. Let's go. Let's understand this notebook. I will share this notebook in my GitHub. I choose a red wine dataset. She's available in UCI, machine learning, and my GitHub has a link to access, but I put this link here. Yes. But first, let's import the Tensorflow, okay? I'm using Google Collaboratory is very good to presentations. We have many libraries and GPUs, okay? collab.research.google.com, okay? Yeah, we have notebooks and libraries, and you can use Python, but if you want work JavaScript, you can, but I prefer Python. From TensorFlow, let's import Keras and layers. It's important. Neural network as build layers. With layers, import NumPy and Matplotlib to make graphics. Now let's import our dataset. It's a CSV. And this line, we have an optional line. If your database can be local, you use this line. Okay, import pandas PD, name, and data of PDS, reads, CSV. Okay, let's see this data. In this data, we have some features. Okay, we have a fixed acidity, volatility acidity, its numbers, of course, citric acid, residual sugar, chloride, free sulfur dioxide, total sulfur dioxide density, pH, sulfates, alcohol, and quality. Quality is our classification, is our label. And then other is features, okay? But let's examine this data. It's not on the same scale. We need to be they are be in the same scale. Remember. Let's understand our data. Data.info. Flows, integer, columns. New data? No. 0. Now let's see descriptive statistics. What's descriptive statistics? Let's analyze mean, standard deviation, minimum, and median. First quartile, max. We describe this data and use transpose matrix because data set is a matrix, remember. Linear algebra. And remember, I said about scale data. I put two functions here, standardization and min-max. I prefer use, in this case, standardization, but you can use min-max and test your data. And the object of these functions is put in the same scale, okay? Let's to analyze our distribution through histogram. Histogram is a very important graphic in statistics and analysis. Okay, we have many fives and qualis 6. Okay. Yes. Remember, split the data into train and set. Okay. 70% to train, 30% to test, but you can do other form, other way. 8%, 50%, 20%, but it's important the train 70% to train, more data in training. Okay, in this case, we split and training data set and test data set. Okay, and it explicits features from labels, because feature is your training and algorithm. It labels in our classification. After feature scale and train data. Remember, our data set is not the same scale. We must be in the same scale. In this case, is standardization and training data and test data. Okay? Standardization is a process of putting different variables in the same scale. Okay? But you can use min-max too. Other formula. And finally, our model. Let's see here. You have a function def build model, Keras sequential. We have 3 layers, okay, and 64 neurons. And the activation function, it's ReLU. Its input shape is our features. After a hiding layer, the 64 neurons, we have activation ReLU and our classification, an output layer. You use optimizer to better learning in our model and REMIAS probe and compile our model. But we have evaluate our model. We use the matrix mean square error and mean absolute error. Okay, mainly mean absolute error and returning our model. Okay, let's build your model. Summary of our model. Let's train our model, but before, let's understand what is callback. Okay, callbacks very important in TensorFlow. Okay, what is callbacks? Callbacks is an utility calling certain points during model training. You can execute some functions in our training during our training. In this callback, early stop. It will stop the training where there is no improvement in the validation loss for 10, and again, patience, for 10 consecutive epochs, and 10 consecutive epochs is no improvement, stop. The monitor is the matrix mean absolute error. But this callback it's TensorFlow, but you can create your callback functions. It's easy. Class my callback t.keras.callbacks.callback def on epoch end. You can learn more about these callbacks and website TensorFlow. Okay. In this case, you use mean absolute error to cancel the train, but minus 0.05. Okay. Is an example. In our model, we use early stop. We have 1,000 epochs, but it will stop because our callback. Okay, let's try. It stopped and 158 epochs. But you can adjust this model. It's not obligatory, but you can adjust. Okay. Let's evaluate now. In object hist, you evaluate our model. We have a loss. Our loss is the same mean absolute error. Mean absolute error and mean square error are two formulas very important. I recommend you understand this formula because you can use mean absolute error or mean square error in regression problems. Okay. Let's see through graphic. And this function, we plot a graphic and mean absolute error and mean square error. Okay. Let's see this graphic. And remember, we stopped our training after 158 epochs. After no improvement. Observe the lines. And mean absolute error. Mean absolute error is very common in regression problems. Okay? It's a good metric. But we are training. But now it's hard to test. Okay? Remember, now testing data. That's the set. Okay? And test labels. Remember, we have a 30%. Okay, when we have a 0.54 quality, and mean square error 5245 0. Make predictions now. With training, test, make prediction, but you use the testing data. Okay. And evaluate testing prediction. Remember, our labels are concentrated in 4 and 8. This line is a linear regression, and points are data points. Okay. Now let's evaluate error predictions. Some errors, but 0 and more port. We finish our notebook. Let's continue. I would like to recommend a great course. It's machine learning crash course in developers.google.com. Is a perfect course to beginners, and you can access this course. Is easy, is very good. Okay, crash course. Remember, you can access in other websites, other courses. I recommend Udacity is very good. Coursera, many courses with good topics, explain. You can access. I recommend. And I would like to emphasize, you need to practice. Use your notebooks. You can use Colab. You don't need to install any libraries in your computer, but if you want, you can. But you can use it. Google Colab. It's wonderful. It's very good. Kaggle, have to. And thank you for attention. It's my LinkedIn. LinkedIn Jéssica Costa Info. My Twitters are Jéssica Costa Evelyn. My email jessica.sc.info@gmail.com. Thank you, Amanda.
Hello! I removed my camera and I don't know how to put it back. Technology. Difficult stuff.
Oh my God. You can send me doubts, suggestion in my email. Okay? It's in my...
So we have all the information from Jéssica here, her LinkedIn, Twitter, email, take your screenshots, or this talk is going to be available online as well. Jéssica,
I like suggestion too. Share knowledge, other notebooks.
Yeah, there were many people who were happy here. They were sharing. Thank you for doing this. There's people from all around. There was someone from, I think, Nicaragua. Where was
Nicaragua?
Yeah.
Laura
was saying Nicaragua.
It's Laura.
Yeah. Thanks, everyone. If you have any further questions, you can chat to her on those social media links she's shared. And thank you, Jéssica, again on a Saturday, giving your time for the community. Huge appreciation. Thank you.
Thank you.
See you later.
Eita.